Okay, great. Thank you. Voice from the data center. All right, so let me hide these controls. Um, okay. So good morning and happy Wednesday. Today being Wednesday, not only is it so-called hump day, it's also lab day. And for today, we're gonna do some practical exercises focusing on two things. One is a solution to project number one. And I stress the word a solution versus the solution because there are many ways that one could enterprise to answer and solve project number one. And then I hope to spend about maybe no more than 25 minutes or so on that and walk you through PyCharm. But I'll begin that with some slides to hopefully put you in the mind space of the solution and also enterprise to show you an example of what I mean by thinking of the algorithm before jumping right into the coding. And then for the balance, which will be the majority of the time, I'd like to talk about Jupyter notebooks and use that as the mechanism to show you various constructs about visualization. And we'll be looking at the matplotlib libraries, specifically pyplot. Okay, but before we begin, any questions on anything about life, about the weather? No? All right. Okay. So hopefully your breakfast was a good one and you're raring to go on this cold Wednesday morning. Okay. And so in the solution, and what I'll do is go over some of this and then pivot to PyCharm and show you the realization of it in code. And so with this, the assignment for project number one was to take all of the individual data files, which was provided for you in code, consolidate that into a single data file in CSV, and then you were to add another column of information, where that column of information was a set of strings that enumerates the year and the month from January 2012 to December 2020. And so with that, I write out a CSV file with the new version of the CSV, which I call new CSV data or something like that. And that's provided for you as a CSV along with the solution for project number two. And so project number two is purposed with getting you practiced in Jupyter with various visualization APIs. And we carry forward in project number two the spaghetti meatballs index problem with some summary statistics. But the focus primarily, or at least the goal for project two, is on visualization. And so we'll certainly revisit visualization when we talk about data frames and the Pandas API. But for now, we're going to do visualization in Matplotlib, assuming that things are NumPy arrays, Python arrays, and read in from CSV files. Okay, any questions? No? No questions? All right. So good morning. So we begin with an array, and this is just a visualization. And if you've taken a class with me before, yes, oh no, the sketch pad is back, or animation pad. And so with that, we have a couple data structures that I'd like to focus on. We have the existing header, and that existing header has an entry for each of the food items, and that's going to be ultimately written out to the CSV file as the header row. Now, of course, since you're adding a column, that particular column is going to be the date. And it's going to be in the following schema where you have the month followed by the year as a string. And so we need to augment that data header to include a column label or variable name, if you want to call it that, since our discussion of random variables. But we need a new header entry for that column that I'm putting in this 0th position. Okay. And so we start out, and in this particular example, and this isn't the only way to do this, we have our existing header file or array or vector. In my math background, I like to call it a vector, even though it's an array. We have our existing vector of CSV headers. There's strings, broccoli, spaghetti, chuck, and tomato. Hopefully I spelled tomato correctly. And we want to include date as that new entry in the 0th position for our vector of CSV header names. And so we start out in a loop block, and we're going to use the iterator in all data header for the existing one. And we're just going to go ahead and we're going to append to this new column date. We're going to append each of the entries given to us by the iterator in that loop block. Now, I just say loop in general. If you were going to implement the syntax of Python, you'd say for, and then give it a dummy variable, and then go through the iterator. But in this case, we're using append, and append means to add to a new entry in this top level array, whatever that dummy variable label is that exists in that block returned by the iterator. Any questions about this? That makes sense? Yes? I did? Okay. I promise you, I will misspell things all over the place. My best friend is a spell check. Thank you for that. I misspelled broccoli. All right. So when this loop exits, when it halts, we get a version of new data header. And you'll notice here in the 0th position, we have that date string. And so each time we start out with date, and then we have date and broccoli, date, broccoli, and spaghetti, date, broccoli, spaghetti, ground chuck, date, broccoli, spaghetti, ground chuck, and tomato. Does that make sense? Are there any questions? And you'll notice here, I'm focusing on what happens to the data structure, right? And certainly you could write this out as an enumerated list describing your algorithm before jumping in to the details of the Python implementation. And in particular, as our projects in this class get more and more sophisticated, and it's just good practice in general, it's important to focus on your algorithm, the operations you apply on your data structures, and what the result is before those operations and after those operations, so-called preconditions and postconditions on your data structures. Once you do that, then code it up. And then the consideration becomes, what are the syntax for doing iteration in Python? What is the syntax for appending to a list in Python? And when you think at that level, it sort of separates your concerns between the progress that your computation is making and the particulars of the implementation details of the language. Because it's very often the case, and I encounter this all the time in my research, that you're going to be implementing in all sorts of different languages, in C++, Java, Python, MATLAB, all sorts of things. Any questions? Does that make sense? No? Right. So then we want to create that new column. And we're going to populate that new column with that stylized string that is in this case, a month-year format, iterating through all of the months of interest and all of the years of interest. And so to do this, we know we have two quantities. We have the months, which we know are January through December. You could choose to populate or pre-populate an array with all of the months of the year. And then we know what the date range is in terms of the year number, which is 2012 to 2020. So certainly I'm going to need iteration, not just one level of iteration. I'm going to need two levels of iteration. So here you see this block. It has a loop. There's an outer loop for iterating over one of those quantities of interest. And in this case, it's the year. And then there's the inner loop iterating over the other quantity of interest, namely the month within that particular year. Now I put the month in the inner iteration because for each year, I want to go from January through December, respectively. Are there any questions about this? Yes. Yes, yes. Any other questions? No? All right. So it's really important to understand what I like to call the mind space of the problem before going through the implementation. And you could very well take something like this and implement it or realize it or mechanize it in Java, Python, C++, C, what have you. It doesn't really matter. Okay. So we iterate over the years. And of course, when I show it to you in PyCharm, in Python, there are certain idiosyncrasies about how you do that in Python. We'll talk about that. And we iterate over the month. And we start out with an empty array or vector. And on each statement within this doubly nested loop, we're going to construct a string and add the month and year to that array. And so we're going to start out in 2012 and go January through December, then 2013, January through December, and so forth. As a result, when this doubly nested iteration halts, we're going to end up with this array, in this case, calling it new column. is going to be populated with that month and year string starting January 2012 and ending in December of 2020. Any questions about this? Does that make sense? Yeah. All right. So now that we have this new column, now we want to effectively paste it as a new column within this all data that we had as a result of the example code from project one. So we know that there are 12 months, and we know that there are a total of 9 years going from 2012 to 2020. And so I set up, and I like to do it that way, constants, what I call number of measurements, and we're going to have yet another iteration. Because essentially what we want to do is we want to take each row from that new column and each row from our consolidated data table and paste the two together so that each entry respectively from new column is appended with the row respectively from all data. Does that make sense? Any questions? Okay. So we're going to do that for the 0th row, in that case, January 2012, and the 0th row from all data, which in this case, just an example, made up the numbers on the slide, 1.2, 1.3, 2.07, and 4.0. So then it would behoove you to look up how you put two things together that ultimately are arrays. And there are two ways to do this. One is append, and one is extend. But the semantics or the behavior is different, right? And that should be something you should look up and put in your research notebook. And we'll talk about what that difference is when we fire up PyCharm. Secondly, the other thing to concern yourself with, see if I can remember what I was going to say, append, iterate, extend, something else I was going to say, I can't remember. Brain hiccup here. It'll come to me. Okay. You're going to iterate and you're going to put these two together. And then once you have this consolidated entry that includes that new column's worth of information, you're going to put it somewhere. And in this case, we have new all data. And each time we paste together that entry from new column with that entry, that's what I have to remember, sliced from all data, you then stuff it in new all data as a new row in ultimately what is a two-dimensional array. And so then that question, in addition to how you paste things together, is how you extract row by row from something which is a 2D array. And you're going to use slicing. And when you slice, you're first going to say, pay attention to the 0th row, the 1st row, the 2nd row, the 3rd row. But that second argument of the slice, you don't care about what column it is. You're going to use a wildcard so that you get column 0 through that last column. Any questions about this? Does that make sense? Yeah. All right. So let's go ahead and I'm going to exit the PowerPoint. And I'm going to go into PyCharm. And every time you exit PowerPoint, you lose the share for other things. So let me go ahead into PyCharm, share that, and let me maximize that. Okay. So here we are, and this is main solution. Let me hide meeting controls. And some things I'd like to point out is oftentimes when you're in the IDE, you have this construct called a project. And a project is nothing more than a named collection of code files, Python files in this case, as well as other data files you might have and perhaps configuration information. And so with this, what's really important to pay attention to is the project settings, in particular, what the IDE is set to run when you execute the debugger or the run. Now, running is different from debugging. When you run something, it'll go through, but doesn't let you set breakpoints, examine variables, and things like that. And so there are two different controls in PyCharm. There's this triangle here, green triangle, to run. And then there's this, looks like a ladybug or something, a bug for debug. And debug affords you the ability to set so-called breakpoints where you can freeze the execution of your program and you can interactively both examine as well as set information in your data structures. And so when you go into this control, you'll notice there's a choice edit configurations. And here you have what's called a script path. That's going to be the program you're going to run. Now you notice here, it says main solution.py. I've already set it up ahead of time. So sometimes what you'll find when you're in your IDE or PyCharm environment, you'll run something and you'll be like, why didn't this run? I edited my code. So it's important to pay attention to what the target is or the program that the IDE is set to run, because that could be different from the file that you've opened. It does give you the ability in the IDE to select a file and right-click on Mac is control-click, and you can say run this particular file different from the file that's set in your settings, all right? So that's one thing to pay attention to. If you find you've edited your code, you've made some changes, you run it in the debugger, or you run it in the IDE, I should say, and you find that, well, I don't see the result of my changes, you want to check what the script path is associated with the settings for that particular project. Okay, any questions? No, that makes sense? All right. So now I'm not going to go through the part that reflected the example code, and the example code ended in the closing of the all data file. And that all data file, to jar your memory, it took all of the entries from the 4 CSV files for each of the food items. In this case, broccoli, pasta, tomatoes, and chuck, which is a cut of beef. I don't know different cuts. I know what tastes good, but I don't really know the parts of the cow. Anyways, that being said, we're going to set a breakpoint here on line 126. And to set a breakpoint, you click in the margin, and you notice when I do so, I get a little red dot. Now, if I tried to set a breakpoint on the line above, it's not going to let me. And the reason for that is when you set breakpoints, it has to be on executable code. It will not let you set a breakpoint on something that is not an executable statement. And because it's commented out above, that's a comment, it's not executable. The debugger won't let me do that. So let's go ahead and let's debug it. So here, let me come down to the, go up here, oops, debug, and it'll load. And then you'll notice now, it gives me a highlight on line 126. That means my execution has stopped at that point. And so some of the things you'll see here, you have two windows. One is called the debugger window down below, and the other is called the console. Now the console is the command line. And that console, every time you make a print statement, it'll send to the console whatever it is that you printed in your program. Now, in this case, along the way, I print out the shape or the measurement of the size of various data structures. The 108 comes from 9 years times 12 months. 9 times 12 is 108. And so it's very useful sometimes to do printouts in your code, but that can get very cumbersome if you have a lot of places where you're printing out. And so one practice I like to make is every time I have a print statement, if it gets very unwieldy, I have an if clause, an if block with a variable called debug, and I can set that variable globally as true or false, so I can effectively turn off the verbosity, the number of print statements effectively. I can turn it back on by setting that debug variable to false, to true, I mean. Any questions? No? All right. And so the other window is the debug window. And that's where kind of, the magic happens. If I go to debugger here, you'll see an alphabetized list of all of the data structures that you have in your program. And so here we have all data, and all data is one of the data structures that I talked about. And one of the things that it gives you is a rendering of the actual data comprising your data structures. It's a two-dimensional array, so you'll see an outer array, and in each position is an inner array, where each inner array has 4 positions in it. One for broccoli, one for spaghetti, one for chuck, and one for tomato. Okay. Any questions about this? No? Make sense? All right. So now that we have this, let's go ahead and drive around, and we'll take a look at this algorithm that I described in the PowerPoint. So I'm going to single step, and the first thing it does is constructs new all data, and that's going to be the global data structure in which I will populate those two things I alluded to an entry from that new column and that row, that entry from all data. Now, I've already closed the CSV file, but because I'm in the same program, I still have all data in memory, and that was what I used for the CSV file. Now, in project number 2, you're just going to be reading that CSV file from memory and constructing that table from what you've read off of CSV. Okay. Any questions? No? And so I create that data structure, okay? And you notice here, new all data is here. I can expand that and it's empty. I haven't yet added anything to it. So I start out, there's new data header, and new data header, as I said, is going to contain that label that I'm going to use to augment what's going to be ultimately the header entry for this modified data table. And so I start out and I take the iterator for all data header, and all data header, if I hover over, I get a tooltip in the debugger, and it pops up the value of that particular data structure, all data header, broccoli, ground chuck, spaghetti, and tomatoes. Okay. Any questions? No? And so I iterate through that, and I won't do this for everything. For that 0th instance of the iterator, once I'm inside of the block for that iteration, this dummy variable label is set. It's active. It has the so-called scope or existence within that particular block. And so that label variable is going to be assigned each one of the instances that are grabbed from that all data header vector by the iterator. Okay. So if I were to look at label here in the debugger, you'll notice it's a string and its value at the moment is broccoli, right? So I really encourage you to get comfortable with your debugger and interactively examine the state of your data structures as your computation proceeds. All right. And so the next one, I append, and now you'll see new data header has date, that's what it started with, and now I've added broccoli to it, right? So it's working exactly as I had intended. And so it's really important to resist the temptation to want to jump in directly into the implementation. You don't want to implement something before you're sure about what it is you're trying to implement, right? Resist that urge. Okay. Any questions? No? No questions? All right. So let's go past this block and let's look at the creation of the contents of that new column. So I'm just going to go ahead and continue my execution, resume program. And now I create that new data structure, namely, new column, okay? And you'll notice here, I'm choosing names that are kind of descriptive about what the purpose of them, these data structures are. And it's not incorrect to call it A1, right, instead of new column, but your program, as much as possible, should be so-called self-documenting. Choose good names for things because it makes it easier for you to understand after the fact and someone else reading it to understand what's going on. When you get out into the marketplace, very rarely will you be implementing things anew. Oftentimes, you're going to be implementing or changing things in existing code. And so it becomes really, really important to exercise good software engineering practices when you craft code. And that means choosing good names for things like your data structures. Any questions? No? No? Quiet? Still tired? It's cold? Hungry? Need coffee? No? All right. Okay. So we create this new column, and it now is in existence, and we can see new column is a data structure. We can examine it in memory in the debugger, and it's not populated with anything. It's empty. And so here now we have this doubly nested loop, that iteration that I talked about, and we iterate over two things, over the year and over the month. Now it's my style, and you don't have to do this. I just have done this since I started programming decades ago. I like to, every time I have constants, I like to define them as explicit variables, and I use all caps for those to note in my code that this is a constant. Now, that's just a practice from C and C++ that I always carry forward regardless of the language of implementation. And so up above, if we look at start year, end year, we have up above, you'll notice start year and end year are defined as so-called global variables up above, right? Now, the nice thing about that is that if you wanted to change that in your program by using them as variables or implementing them as variables, this level of indirection, if you had this in like 10 places in your share screen, continue on with PyCharm, share. I apologize for that. Okay, so maximize, and we're back. I'll just do the editing to stitch those together. So good programming practice is to use this level of indirection so that when you use this information, use the variable, and therefore when you change it, you only change it in one place, and that's up above. Okay. Any questions about this? No? All right. So why don't we come down here, and we had left off in the iteration in doubly nested loop to range over the year and to iterate over the month within each year. Now in Python, what range will give you is a list of integers, whole numbers, ranging from some start to the end minus 1. And so here you notice I say go in the start year. Start year is 2012. I'll hover over and you can see the tooltip says 2012. And the end year is 2020, but I add 1 because that's the peculiarity of this particular API call within Python. If I did not add 1, it would go to 2019 and not to 2020, okay? But you don't need to know that until you know that you need an iteration. And then once you know you need an iteration, then you look up the idiosyncrasies of the particular language syntax. And that's for the range API call in Python. All right, any questions? Does that make sense? And so now for the month, I've decided to iterate over the number of months, and we start from 0 to 12, and months, that constant is set to 12. But I have an array that I index, and that array is up above, a data structure, and it's populated with all of the months of the year. So let me see if I can find that. Here we go, the months, right? It's descriptive, and we have strings from January to December to represent the month. Now, again, this is a solution, not the solution, right? There are many ways to do this. And it's my style when I write a program so that you kind of see where everything is. You have this expectation. I have all the imports that I need up above. I follow that with constants and then data structures. And then I have my support code. And then lastly, I have my main entry point, my main routine. Okay. Now, of course, you don't have to do it this way. But for me, it just creates this muscle memory that I know what to expect in which part of the code. Now, of course, even over the course of a semester, if you look back at the code that you've written, well-written code is easy to understand, and it's very easy to forget all the details of code that you've written yourself in the span of just one semester. Any questions? No? Make sense? So let's go down and let's continue here. And so we have two iterations. We have over the year and we have over the month. So let me just go through one pass of this iteration. I'm not going to do all of it. So year starts out as 2012, that dummy variable whose scope or existence is within the outer iteration. And then we step again. Month is now month 0, which has scope or its existence within that inner iteration, that for loop. So we extract the date string using our month position, and we notice our date string consists of whatever position of month we have. In this case, it's January, and we create a string out of that number for the year, which is 2012. And we just append an underscore between the month and the year in this case. And so if we look at date string, I'll just hover over that, is January underscore 2012. Okay. All right. Any questions about this? No? All right. So now I go ahead and I say, okay, well, I'm just going to append that to new column. And I do that for every single combination of the month with the year as a suffix. Okay, so let me go ahead and let me set a breakpoint in the next block for iteration. And I'm going to resume my run. And if we look at new column, we notice here in the debugger, we have January 2012, February 2012, up through and including December of 2020. It doesn't always want to show you all of the entries unless you go ahead and you tell it to show it to you because it's trying to be compact in showing you things about the runtime state of your program. Right, any questions? No. Oh, that's someone else outside. Okay. So now, lastly, we're going to do that part we talked about where we're going to paste in the new columns data with the existing data containing the measurements of the 4 food items. And so we start out here, and I have another global constant here set to num measurements. And that's nothing more than the product of the number of months, which is, thank you, which is 12 months, and the number of years, which is 9 years. And so num measurements will always be 108. And so here we range over 0 to num measurements. And because array access is zeros based, I don't add 1, right? I did that in the other case because I needed it. So in this iteration, we go ahead and let's step over. Now, I is an integer whose scope or existence is only within this iteration block, that for loop. Let me collapse a few things here. And so we start out and we're going to populate a record. And a record is going to contain 2 things. It's going to contain a particular row from that new column, which is just going to be one of those strings that has the month and the year. And then I'm going to extract by slicing a row out of the all data 2D array, which are the 4 price information for the 4 different ingredients. And then I'm going to paste them together, right? And so here I construct an array and I call it rec for record. Couldn't think of a better name. And if we look at rec, we see here, it just contains a string January 2012. So that's from that new column that I alluded to. And now here inside, we have all data, the ith row, and you'll notice for the column, I have just a colon. That's the slicing notation. And if I don't have a start and a stop for the slice, it assumes the smallest start, which is 0, and the largest stop, which is the length of the row minus 1. Okay? Any questions? Does that make sense? All right. So now you'll notice here, I say rec extend. So I say, take that array that has January 2012 in it, and I want to add to it or paste to it that first row from all data. Now, if I did append means to place that object as the thing after or follows that entry inside of rec. And so if I said append instead of extend, I would have January 2012, comma, and the next object is going to be that array of 4 entries. Append means to place it there. Extend says go into that array and take element by element and add each element by element to that first array. And so part of the task list for project 1 was to look up append versus extend, right? It's a really important semantic difference. I know I want to paste the 2 together algorithmically, but the peculiarity of Python is that you have these 2 different versions of paste together. Any questions? Does that make sense? Yeah? All right. So if I do that, let's first look at the state of rec. And we see rec here in the debugger. It's just an array with 1 item, January 2012. If I do iterate or go over this extend, you'll notice now rec, oh, it's up there, has January 2012, and then it has the value of those 4 food items. Does that make sense? Any questions? No? All right. So I'm not going to iterate over all of them. So let me clear the breakpoint for that iteration. And I'm going to come down here. And after this loop halts, or I exit this loop, I should have new all data has all of the entries consisting of the 4 data items prepended with that label. And so if I look at it in the debugger, I have January 2012, and there's the data. February 2012, there's the data, and so forth. Any questions? No? Okay. So I hope by at least the middle of the semester, you become very, very comfortable with the debugger. It's an amazing tool that really helps you understand what your code is doing and to write error-free code. Very helpful. So then I go ahead and I write that out. So I construct a data file. So let me step over that. And there's the file path for new all data. I put it in the current directory and I call it new all data.csv. Okay. And then I go ahead and I write it out. I'll create a CSV writer from the file that I open. I go ahead and I first write the header, and that header has all of the variable names, including that new column, which I'm calling date. So let me iterate over that. So the first thing I do is I write out the header, and then here for CSV writer, there's an API call called write rows. It's not incorrect if you iterated and then wrote each row, but write rows is there for you, right? So I would highly recommend doing that. It'll just iterate over all of the rows in the 2D array you give it and write it out to disk. Okay. Any questions? Does that make sense? Okay. So let's go ahead and let's just finish that run, and we're done. Now, it's my style that I like to have a printout that lets me know at the console that my program is done. It's not incorrect if you don't do it, but I just like that practice. All right. Any questions? No? All right. So let's exit here, PyCharm, and let's continue on with Jupyter. And we will go back to sharing the PowerPoint. All right. And so let's see, share. Am I still recording? Yeah, I'm still recording. All right. All right. So Jupyter is a web-based system that runs a version of Python called IPython. And it is a mechanism that you use to implement so-called live documents. A live document is different from what you'd see as your Python file because it's interactive. Interactive meaning you can display things, and it's a wonderful tool and is very popular in data science community for visualizing your data and for experimentation, right? And so this Jupyter is implemented as a server, and it runs your interactive Python session from your browser, and it wants to bring up your default browser on your platform. So if you're running Mac OS, it'll bring up Safari. If you're running Windows, it'll bring up Edge, Microsoft Edge. And if you're running Linux, it'll bring up Mozilla Firefox. Okay, and so it's a collective. Jupyter implements what's called a notebook, and a notebook is a collection of these so-called live documents. So let me go ahead and go to the command line. Let me bring that up, and I will bring up Jupyter and show you what it looks like. No, didn't mean to do that. The terminal. Okay, share. So this is the command line terminal, and let me just start by deactivating Anaconda. So when you run Anaconda, I like to do it from the command line. There are menu-based ways of doing that. And as I said before, Anaconda is an environment in a previous lecture that collects together names associated with sets of tools, both the version of Python as well as the libraries under a name. And when you install Anaconda, one of the things it sets for you is a starting or so-called base environment. And so at the command line, when you run Anaconda, if I say conda activate and don't give it any name after that, it's going to run the base environment. If I had other environments defined, I'd give it the name of the environment. So let's say you're saying project 3, right? You create an environment for that. And maybe project 3 might use other tools different from project 1. And so that's just a productivity tool that allows you to manage all those different versions of libraries and Python versions that you might use across various projects. So I'm going to say conda activate, and you'll notice one of the things that changes is my so-called command prompt, and you see this string here, this prefix base. And so that's Anaconda telling you what environment you currently set to. And it's up to you to remember what particular tools are associated with that name, but you can certainly look at something called your configuration file, and we can do that another time. And so here you'll notice if I say PWD, present working directory, I'm in a directory that I call at my top, deepest directory, Jupyter Notebooks. And inside of Jupyter Notebooks, if I do a listing, you'll see files that have an extension called IPYNB. That's the extension for these IPython files. And these IPython files, you can't really edit them. You can take a look at them, but it includes binary information because it includes things like fonts and pictorial elements that you might display, like the visualizations in your project. And so I'm going to go ahead, and I've already installed it, but if you wanted to install Jupyter, you would use the command at the command line, conda install, and then Jupyter Lab. I've included on the course resources section of the Canvas site for the class something called the Jupyter cheat sheet, and that walks you through, or at least has the commands you use to install Jupyter within an Anaconda environment. Okay, any questions? No? All right. So let me go ahead. I've already installed it, and I'm going to say Jupyter Lab. And when I run Jupyter Lab, it starts a server, and that server is running on my laptop. And it's going to then run my browser, Safari, and it's going to point my browser at that particular server for my interactive notebook. And so I see a bunch of things here. I can run a console, a command line, and start writing Python commands, or I can create a so-called notebook. And this notebook is nothing more than a document. I'm going to go ahead and bring up this empty notebook. So it's an existing IPython file. And let's kind of drive around a little bit what this notebook looks like. Now, this notebook looks a little bit like a debugger, right? You have code, and you're effectively executing statements of code, but it's not a debugger, right? It's more of a visualization tool. There's no interactive changing and examining of the contents of your data structures in a Jupyter notebook. In a Jupyter notebook, there's no notion of a breakpoint. You just can't do it. You have a series of so-called cells, and in each cell or text field, you can put valid Python statements. And if you don't put valid Python statements, it's not until you run it or execute what's in that cell that you'd see that there's an error, right? And so what it does is every time you execute statements that are in a cell, it gives you the result of that execution, be that graphical or text-based output. Okay. Any questions? That make sense? And so if you've ever run Python from the command line, Jupyter is basically a prettier version of running Python from the command line. Okay, question? You would have to go back to your IDE, to your debugger. And so, and that's an important question you ask. So thank you for asking that. And so if you're going to debug something, use the debugger to do it. And then once you're convinced, if it's something that has a lot of moving parts, or maybe it's pretty complex, use the debugger to make sure that you know that it's going to run. And you can always copy and paste it from Python from the debugger, into a cell in Jupyter. But where the real power comes from a notebook is in your visualizations. Okay. Are there any other questions? Yes. I'm sorry. With different notebooks, yes. But this particular one, it's not a traditional debugger, right? It's more so for visualization. You can get plugins to do all sorts of things with notebooks, but the out-of-the-box plain vanilla, it's not really set up as a debugger. One thing you can do is change the so-called kernel, and the kernel is just a name for the version of Python that supports this particular document. Okay. Any other questions? Does that make sense? And so, yes, there's all sorts of variations to every system, right? And that's part of the beauty of open source development. So I'm going to bring up the slides, and we're first going to walk through some elements of visualization, and then we're going to switch back to the Jupyter Notebook in order to ground this out. Okay? All right. So let me go ahead, and I'm going to make sure I have the Jupyter Notebook up, and I'm going to go back to PowerPoint, and we're going to continue on. All right. And so we start out when we look at our figure environment, we're going to use matplotlib, specifically pyplot, and it all starts with this idea of a figure. And you can think of a figure kind of like as an artist's canvas, right? Let me select, I'll use blue. And when you want to draw, one of the ways you can draw is on a figure. And a figure, you give it an identifier. In this case, I call it figure 1. And that figure you can think of as a canvas, and that canvas is identified by that numeral that you give it. So if you can have a figure 1, you can also have a figure 2. And when you call plot figure, you're setting the context to that particular canvas. And after setting the context, saying bring up this particular canvas, every graphics command that you issue will be made to that particular canvas and displayed. So you can set the context to something else, and there's more than one way to do this, right? At first approximation, I don't make the assumption that you've done this before or used Jupyter Notebooks. I don't think they do that in 120, do they? They do in 120. I've heard someone nod no and see people nodding yes. Kind of so-so. A little bit. Okay. And so here I set the context to figure 1, and then I go ahead and I plot. In this particular case, plot is a line plot. And so you notice here I have vector, and you can imagine vector is just an array of numbers like 5, 3, 17, 11. And inherent with that vector is the position of each one of the elements of the array. This is position 0, position 1, 2, and 3, respectively. So here I'm saying, give me a line plot, and that line plot, the default, will be the position number 0, 1, 2, 3 along the x-axis, or the horizontal axis, and along the vertical axis, the y-axis, is each one of these values. So let's say if that were 3, if this were 5, and I know that's not to scale, and maybe we have 17 here, and maybe 11 is right below. So we're going to have, starting from origin, we're going to have 5, 3, 17, and 11. Okay, and my artwork is horrible. All right, but if you specify 2 vectors to plot, so if you said pyplot dot plot, and you gave it an array x values and an array called y values, for it's going to plot x versus y in 2 dimensions as a line plot. Okay. Any questions? Does that make sense? All right. And so for part of project 2, certainly you're going to be plotting a number of things. You're going to be plotting the food prices over the date range under study for each of the 4 food items, as well as the SMBI index, which is just the sum of the price for each period, reporting period, for each of the food items, across the food items. And so if you have a graph, of course, you might want to label the axes for reporting purposes. When you say X label, give it a string. It writes your string as your label down here for the x-axis, and your string along the y-axis. You can also give the graph a title. I'll show that to you inside of the Jupyter Notebook. Okay. And so all sorts of options you can have for your plotting, so much so that I can't possibly teach it to you. So that's where you go off to the documentation. It's all over the place, both the official documentation of record for Python, as well as several people have their blog posts and their articles about how to do various things. I personally prefer to go to the documentation of record because they're the ones who wrote the APIs and they know what their intent was in its implementation. Okay. Any questions? No questions? Okay. And so another thing that you can do is make so-called subplots. And when you subplot, you're effectively taking your canvas. So here is my canvas here. And this has an identifier, figure 2. So that's setting the context to that particular canvas or figure. And when you give a subplot takes 3 different parameters. You have what's called the row slice, and you have what's called the column slice, and you have what's called the index. Now, when you give a row slice and a column slice for a subplot, you're essentially tessellating your canvas into the number of rows. So we say 2 rows. So that's this slice. You have the first row and the second row, and 2 columns. You have the first column and the second column. Now here it's 2 by 2, but I could have said subplot 2 by 3, and we would have gotten something like this. My row slice is 2. My column slice would be 3. Now, when you access this, you access it in order to draw on that particular cell in the tessellation of the canvas. And so when we do this numbering, we number it row major. And so if we did a row slice of 2, that's my row slice. And if we did a column slice of 2, that's my col slice. I number it row major. And so if I say my index is 1, it refers to this cell. Index is 2 refers to that cell. Index is 3 refers to that cell. And index is 4 refers to that cell. And so here, if I say subplot 2 to 1, that refers to anything I plotted after that subplot 2 to index 1, that's going to be drawn in this region. Okay? All right, any questions? Does that make sense? Okay. If I say subplot 2 to 2, anything I draw is going to be drawn in this region. Let's say I drew a different graph, right? Or maybe this is broccoli, and maybe this is tomato, right? Anything when I say subplot 2, 3, it's going to be drawn in this quadrant, right? And anything 2, 4, it's going to be in this quadrant. My index is 4. Likewise, if I had a tessellation that was 2 by 3, a row slice of 2, and a column slice of 3, this is going to be index 1, index 2, 3, 4, 5, and 6. Okay. Any questions? Does that make sense? Oh, yes. It does not start from 0. Why does it not start from 0? I always used to joke when I was in industry, because whomever implemented this feature missed the meeting, the engineering meeting, and didn't know it should start from 0. But I don't know why it doesn't start from 0. It starts from 1. Okay. Any other questions? No? Make sense? All right. And so lastly, let's look at histograms. A histogram takes a vector and it represents a visualization of your distribution. And we'll talk about, well, we did talk about probabilistic summaries. We've been making summaries of it, but we'll be talking about other stuff as well. And so one of the control variables for the histogram, after you give it the data, is the number of bins. Now, this number of bins is very, very important, and it defaults to 10. But when you set the number of bins, you really have to think a priori about your data. So for example, if you had an analysis problem where, for example, you're looking at the ages of a group, maybe you might set the bins to be 100 bins. And in that case, you could represent all ages from 1 to 100. Maybe you're more interested in your analysis of the decades, right? People in their 10s, in their teens, in their 20s, 30s, and so forth. And so when you set the bins, what that refers to is the number of partitions across the span from the minimum data item to the maximum, and you're chopping it up into 10 equal regions. And then when you iterate over the data points, you're collecting them in each one of those bins. So let's say it was your age group. The first bin might represent 0 through 10. Next one might be 11 through 20, and so forth from 91 rather to 100. And so underneath the covers, histogram goes through your vector. And let's say your vector of data contained someone who was 9, an age for like 12, age for 91, etc. And it iterates through and it says, aha, 9 belongs in this bin, 12 belongs in that bin, 91 belongs in that bin. And on the vertical axis, it just gives you the counts of how many data items from your vector were placed in that particular bin. There are API options to actually draw the envelope for that distribution visualized by your histogram. And you can also use your histogram as a proxy for the ground truth distribution over data and use it for sampling. And we'll talk about stuff like that later in the semester, since our focus here is just on visualization. And so if you had a subplot and you reference a particular cell, and then the draw command that you give it is to do a histogram, it'll put a histogram in that cell. If you do line plot, it'll put a line plot in that cell. Okay. Any questions? Does that make sense? Now, let's go out to, I'm saying, I think that was it. Let's go out to the Jupyter Notebook and let's keep the annotations. My laptop's working really hard. Can hear it. Let's switch to the plot example. And this is on the class Canvas site for lab exercise number 3. I highly encourage you not just to load this and use it, you're welcome to, but I encourage you to write stuff in the notebook and get used to its usage. And so we start out, we have a bunch of cells. And one of the things that's particularly wonky about Jupyter Notebooks is when you write functions, you have to have the function in one cell. You can't straddle the first part of the function, the declaration, and then have part of the block for that function in one cell, and then the remainder of that function block in another, right? For functions, the entire block of behavior, which is your function, has to be in one cell in the notebook, or else you'll get an error. Okay? Are there any questions? No? All right. So let's go in. And with this, we have, of course, the visualization that I made, but you can step through here. We have controls that are just like a debugger. But again, I stress that the out-of-the-box Jupyter is not a debugger. There are plenty of plugins that you can add to it to do debugging things, but the plain vanilla out-of-the-box Jupyter Notebook is not a debugger. So here we have a comment, and if you hit plus, you can add a cell below any cell that's existing. And when you start out, an empty notebook has an empty single cell, and you just add cells and put your code in those cells. So this is a comment, so it doesn't really do anything. I have my import statements. Stylistically, I like to structure my programs where I have the inclusion of the libraries, followed by the data structures, followed by the executable code. So let's go here and let's execute these imports. Now, of course, you run this sequentially. So if you decided that you wanted to use an API library for which you did not have an import, you have to put your execution back to the import because it doesn't have that in memory until you execute that, right? That's really important to remember. Any questions? No questions? No? All right. So let's go ahead and let's go through the import. Now, one of the things you can have is a code cell in Jupyter Notebook, and you can also have a documentation cell, a so-called markdown cell. So you notice here, this drop-down box here, I can select the cell type. I have different versions. I have code, I have raw, I have markdown. I don't suggest using raw, but markdown is a description language, almost like HTML, but it's a lot simpler than HTML. We can have different fonts and all sorts of style for making nice comments. You can display figures and things like that. So if you want to include in your notebook explanations of things that might not look as nice if you have it as a text comment that you would in Python, you're always welcome to include or create a markdown cell in your Jupyter notebook. Okay. And so here, when we execute this markdown cell, it doesn't do anything. And so now I'm going to populate a vector and I'm going to set up a matrix. And let me go ahead and iterate over that. And in the next cell, I just say, show me the contents of this vector. And that's just like running from the Python command line. If I were to add a cell, so let me add a cell here, and I'm going to say, show me the contents of the matrix. All right, I do that, and it echoes back what I have. I could say, show me the contents of the matrix and show me the shape. I execute that. Oops. Size. I think that's the wrong one. No, what is it? It's matrix. I don't remember. Size or rank shape. That's NP is shape. But anyways, I can look at different APIs interactively. I can delete my cells. I can examine the contents of things. So here, see the time. Okay, we have about 9 minutes left. I'm going to plot a figure, and this is called figure 1. And I set the color to green, and there are all sorts of things like line width you can set the color, you can set fonts, you can do, you name it, you can do it as an option. And so one of the things you'll find yourself doing is bringing up the API documentation for each one of these commands for the like 10, 20 different commands and their variations that you can issue. So let me go ahead and plot. I say plot the vector in green, and oops, there we go. All right, so now I'm plotting. So when I plot this, okay, I did it on my machine at home, so it was stored bigger. I can set my color to green. I can set it to, I think that's cyan, and it's cyan. And I can also set labels for the x-axis, label for the y-axis. Grid gives me this set of grid marks. And for certain types of plots, it makes it easier to see what the values are in your plot. Question? Mm-hmm. Oh, like this, something interesting happens here. Yes, it's possible. I just don't remember off the top of my head, right? Absolutely. You name it, they can do it. You can add text, you can add other icons and all sorts of stuff. I just don't know off the top of my head what that API call is. Yes, yes, you can draw things on top of the canvas on the figure. Yes. So here, now let's create a set of numbers. And we're going to do this using a Numpy array. And here we're going to create a set of values from 0 to 4 pi. And in this case, we're not using range. Range is only for a list of integers in Python. Here we use a range to give you arbitrary list of floating points. And so here I create a set of values from 0 to 4 pi in increments of 0.1. And then I call sine, cosine, tangent, and arctangent on them. I add 2 because the values are 0, and if I compute the mean, it's close to 0, and I want to have something different from 0 because it looks nicer, right? And so let me go ahead and let me run this. That's just data. And let me go ahead and insert a cell. So if I said sine x, it displays interactively the data type as well as all the values in that data type. This sine x, let me see if I can run shape on there. It's 126 elements as a vector. It's one dimension, right? And so it's very, very useful to be able to examine things. But again, in the out-of-the-box notebook environment, I can't do the interactive types of things that I can with the debugger, like setting breakpoints, halting execution, examining and changing the contents of my data structures. Okay, any questions? No? All right. So let me go ahead, step past that, and that's a note mostly to myself about what the different colors are in the color palette. Now, that's not the only thing in town. There are color palettes that you can iterate through for all sorts of things like sunflower and mocha, different from basic primary colors. So I start out, I have another figure. I go ahead and I plot the sine in red. I plot the cosine in blue. And this parameter label that allows me to set a legend, right? And Python API matplotlib will associate this label for each one of those plots with the legend, and it'll create the default legend for me. I can certainly modify this legend, like place it in a different part of the graph or change the fonts and do all sorts of stuff. So here I do that and I give it a title. I give it a X label, call it theta in radians, a Y label, sine theta. I turn on the grid, and then the legend, I say, show me a legend, and the location, and if you look in the documentation, it'll show you what all these different options are. I say in the upper right-hand part of the graph. So I go ahead and I do that, and you can see I get my sine, the cosine in blue. I have my sine in red. You'll notice it's not centered about 0 because I add 2 after I compute the sine and cosine. And then I have my legend here in the upper right-hand part of the graph. Okay. Any questions about this? Oh, make sense? All right. And so now, this is the subplot that I was just alluding to. Now here, when I plot the figure, I give it an identifier, canvas number 3, but I have other options for the figure. You can set the size of the figure. Now running on my laptop, if I don't set the size, it shrinks it down, but at home I have a 30-inch monitor, and by default, it makes it really big, right? So here, I'm saying, go ahead, set the canvas, and I want an 8 by 11 canvas. And soup title, whenever you use subplot, you have to give it a title differently because it doesn't know what title you're referring to, the canvas or the cells in the tessellation for the canvas, right? They're different. So here I give it a title. Here's the first index, second index, third index, fourth index. I'm plotting the sine, cosine, tangent, and the arctangent. And you'll notice here when I say plot title, within each cell of the tessellated canvas, I also give it a title. So when you say title inside of a subplot index referring to one of those cells in the tessellation, it assumes that's that tessellation, that cell, and not the canvas itself. So let me go ahead and let me run this. Where did my controls? Oh, you know what? I made that. Let me make that smaller. Let me run that. And here we see our 2x2 plots. We have sine in the first cell in our 2x2 tessellation, cosine. We have tangent, and we have arctangent. Okay. Each one, we have this is tangent, arctangent. Each one has its own label. That's the title. And the soup title, is up above, trigonometric functions. Okay. Any questions about this? Does that make sense? All right. And so we have about 2 more minutes. Let me go ahead and show you the histogram. Oops. So we have a different canvas, figure 4, and we're going to plot cosine with 20 bins as a histogram. So there's our histogram. And so we take our cosine from 0 to 4 pi in increments of 0.1 radians, and we compute the histogram of all of those values with 20 bins. Now, if I go back and set it to 10 bins, 10, by the way, is the default. If you don't specify a bin count, you see that version of the histogram. I can do this in the subplot, or I can do it in the overall figure. If it's in the subplot, again, it'll put the histogram in that particular cell referred to by the index for my row slice and column slice. Any questions? Does that make sense? All right. And so here now, we're going to compute some summary statistics. And the important thing to remember is the version of the summary statistics, whether it's the Numpy version or the Python version, right? And if you mix the two together, it'll tell you you're wrong, right? Okay. So we compute the center of mass, the mean that we talked about. The standard deviation, that version of the dispersion, which fixes up the units, that squared units issue we talked about. We have what are called the order statistics. We didn't talk about that, but the minimum value and the maximum value, the so-called first order statistic and nth order statistic. And then here, this correlation is a measurement of linkage, the linear dependence, and we haven't talked about it formally yet, the linear dependence between two variables. And so each variable's data is represented as an array, and we can call these summaries. We can also visualize the dispersion of the distribution by looking at how wide this histogram is, where it places the probability mass. With this histogram, we can see if we did something like 30 bins, you can see that it becomes smoother, if you will, if you were to draw an envelope. But there's a trade-off between the bin count and the number of measures that you have. We'll talk about in another sitting. Okay, so we can do formatted prints. And this last one is a scatter plot. I thought I'd throw it in because it looks nice. If we plot sine and cosine, that gives you an ellipse. And that's just another type of plot that I'll leave it to you to look up the details of. And so that's time. We're about 30 seconds over. I apologize. So we will end there. And I'll see you all on Friday. We'll pick back up with this idea of distributions, probabilistic summaries, and other measures. I'll see you Friday. Have a great rest of your week.